cos theta is 1 upon tangent theta. 1 upon tan theta. This is known as B upon P, because this is 1 upon B upon P, as I just said. This is B upon base upon perpendicular. This is the 6 trigonometric ratios. 3 are reciprocal of each other, or these are reciprocal of each other. I mean, there are 3 pairs of trigonometric ratios. These 2 are reciprocal of each other. So there are 3 pairs here. 3 pairs of trigonometric ratios. That means total 6 trigonometric ratios are here. These are known as trigonometric ratios. Now let us talk about question number 3. Now question number 3 or third question. Let me explain that proper data. Question number 3, what does it say? Now it says, what are the trigonometric identities? Let me just talk about that. What are the trigonometric identities? These 4 trigonometric identities we have to take the Pythagoras theorem. So let me just talk about it. Question number 3 is, what are the trigonometric identities? Question number 3 is what we talk about. Trigonometric identities. What are these? There are some relationship between these trigonometric ratios. So relationship between trigonometric ratios, they are known as trigonometric identities. How these trigonometric ratios identities are found out? Pythagoras theorem in the right angle triangle. So if I take this as right angle 90 degree angle, and this is theta angle, let me take again ABC. Like this side, and this is hypotenuse here H. This is base here, this is perpendicular here. And by Pythagoras theorem given by Pythagoras theorem. We have Pythagoras theorem says that the square of one side is the longest side here in this right angle triangle. This is known as hypotenuse. This square equal to sum of the squares of the other two sides. H square equal to B square plus P square, this is. Or we can say AC square is equal to base square, that is AB square we have taken, into BC square. AB square, BC square. AC square equal to AC square is the hypotenuse square equal to the square sum of the squares of the other two sides. That's B square plus P square equal to S square. This is Pythagoras theorem. So this is, let me take important one. First equation. If I divide this equation by this AC square, dividing this first by AC whole square on both sides, dividing equation 1 is one equation by AC square, we get, what do we get here? AC square upon AC square. This is AB square upon AC. Let me write whole square, AB upon AC whole square. That also means AB square upon AC square. Sorry, this is plus BC square upon AC square. So let me write here, this is AB upon AC whole square. Here it is AC square upon AC square 1. 1 is equal to AB upon AC whole square. So this is BC upon AC whole square. What is this? AB upon AC. Here AB is base, AC is H. This is B upon H whole square. Now BC is P. P upon H whole square. The first is cos square theta, because B upon H, base upon hypotenuse. that we remember always. P, V, P. Don't catch H, P. First is sin theta, P upon H. This is cos theta. This is sin theta. Second is cos theta. And third, P upon V is tangent tan of theta. Okay. This B upon H is cos square theta. This is P upon H sin square theta. That means this is equal to cos square theta plus sin square theta is equal to 1. This is the first equation, first identity, which is known as sin square theta plus cos square theta is equal to 1. This is first identity, trigonometric identity. Okay, the other two can also be obtained from here. Okay, that is the first trigonometric identity. Okay, now let me find out other trigonometric identities. This is the first one. Sin square theta plus cos square theta is equal to 1 by dividing by AC square. Now if I divide it by AB square, the base square. Okay, sorry. So AB square, or let me divide it by BC square. So dividing first, now dividing first by BC square, let me divide by first BC square. Dividing first equation 1, this 1 by BC square on both sides. So what is the first one? Left hand side will be AC upon BC whole square. I'm writing AC square upon BC square or AC upon BC whole square. The same thing. This is AB square. AB square upon BC square. That means AB upon BC whole square. So this is BC square upon BC square. That means 1. Now, what is AC upon BC? AC hypotenuse upon BC. This is cosec square theta. This is cosec theta here because H upon P cosec theta reciprocal of sin. That means this is nothing but cosec square theta. Because this is AB upon AB is B upon P cot square theta plus 1. So it can be taken as the third one or it can be taken as the second one, doesn't matter. So the second, here I take second trigonometric identity that we write here. Or it can be taken as the third one, this is 1 plus cot square theta equal to cosec square theta. This is the, let me take second one, no problem. If I divide it by AB square, dividing first equation is equation number 1. Now by AB square. So by all the three sides, one by one, we divide by first AC square, then AB square or BC square. So identities are obtained. Obtain identities, we divide the equation number 1 first by AC square, then by AB or AB square or BC square. Now let me divide by AB square here. Now divide first by AB square on both sides. Dividing first on both sides by AB square on both sides. So we get here first is AC upon AB on the left hand side equal to, sorry, this AC square upon AB square, that means AC upon AB whole square. We can write AB square upon AB square is 1. Plus BC square upon AB square, that means BC upon AB whole square. Whenever we write BC upon AB whole square, that means BC square upon AB square, the square of numerator and denominator. Okay, so that is the same thing. Now AC upon AB, AC upon AB, let me write it as H upon B. This is whole square into 1. Plus BC here is P. AB is B. P upon B is P. What is H upon B? H upon B is secant theta. reciprocal of cos theta. This is secant to square theta. Going to 1 plus P upon B is tangent theta. It is tan square theta. P upon B. P upon B. P upon B. Tangent theta. This is tan square theta. Secant square theta is equal to 1 plus tan square theta. So either we take it as some people have taken this as second one, doesn't matter. We can write it now. So this is the third one, and 1 plus tan square theta is equal to secant square theta. So these are three basic trigonometric identities. Because out of these three trigonometric basic identities, we can derive 6 more. Okay, 2 from each. 2 more can be obtained from first one, and be effective. This is 1 equal to sin square theta plus cos square theta. First, this is the first one. Now, out of this first identity, trigonometric identity, we can draw. We can find out. Okay. We can draw 2 more. How? If I take sin square theta to this side, this will be 1 minus sin square theta. It will become negative here. It is 1 minus sin square theta is equal to cos square theta. Here left cos square theta. This is the, let me take second one. 2 more can be drawn from this one. This is the first one. I mean first, second this. And if I take cos square theta to this side, it's 1 minus cos square theta is equal to sin square theta. This is the third. 3 trigonometric identities. This is the basic one. Out of this, these 2 are taken out, can be drawn. There are 3 basic trigonometric identities. These 3 are, expressed in each other. They are just one. They are same. This is equal to this. All 3 are just equivalent to 1. Then, for example, function cos theta is equal to 1. So this from this, these 2 are 1. These 3 are from first trigonometric identity. They are the 3 we have drawn. So similarly, we can find out more. Suppose this second one is we have taken this one, third one. The fourth one is 1 plus tan square theta equal to secant square theta. This is the fourth one that we take. Out of this 2 more can be drawn. If I take tan theta to this side or 1 to that side, tan theta is here. Tangent theta equal to, let me take 1 to that side. So tan square theta is equal to secant square theta. 1 will become negative minus 1. So secant square theta minus 1 is equal to tan theta. Let me take this as the first one. One more. If I take tan theta to that side, this will be 1 equal to secant square theta minus tan square theta. 1 is equal to sec square theta minus tan square theta equal to 1. If I take tan theta to that side, so this is sec square theta minus tan theta. Here 1 is left, so 1 is equal to this. Let me take 6th one. 6th trigonometric identity here. This is trigonometric identity 6th one. And I have taken. Now, out of the third one, this one, basic third one, we can do 2 more, so 3 more are there. So let me take them also. Okay, now let me take here. But this is 6th one, 7th one, let me take 1 plus cos square theta, this one cosec square theta, this is 7th one, we have taken 7th trigonometric identity. 2 more can be drawn from this. What are those? Already 1 is equal to cosec square theta minus cos square theta. This is the 8th one. Okay, this is 1. And if I take 1 to that side, that is cot square theta is equal to cosec square theta minus 1. This is the 9th one. And this one is 1 minus tan theta. These are total 9 trigonometric identities. Okay, a number of other trigonometric identities are there. They are relationship between trigonometric ratios. These relationships between trigonometric ratios are giving us trigonometric identities. So these 9 are basically basic trigonometric identities. Others are drawn I'll just talk about them later. But these are the 9 basic trigonometric identities. These identities which are drawn from this, basic Pythagorean theorem. That Pythagorean theorem is the basic for all these. Okay, so this is how trigonometric identities are. And this is the question number 3. And let me talk about question number 4. Now with the question number 4, let me just talk about that. Okay, so question number 3 we have completed. Trigonometric identities, trigonometric ratios. We talked about definition of trigonometry. We have talked about trigonometry is the study of triangles or measurement of angles in a triangle. Okay, or trigonometric solution of triangles is known as trigonometry. That is also definition. Basically, it was taken from Greek word trigonon means triangle, and metria means measurement or measure. To measure the triangles, known as, or solution of triangles, known as trigonometry. That is how trigonometry defined. Now let me take fourth question. What are the signs of trigonometry, trigonometric ratios in different quadrants? As I just talked about, there are 6 trigonometric ratios. Okay, or 3 pairs of trigonometric ratios. Okay, pairs of. There are total 6, and 3 are reciprocal of each other. So there are 3 pairs of trigonometric ratios. Now those trigonometric ratios, what are the signs of them in quadrants? What is quadrant here? Question number 4, let me talk about it first. The quadrant is 1/4. Quadrant is 1/4 of anything. Now here, the plane, if we talk about geometry, coordinate geometry, then the plane is divided into 4 parts. This is x-axis, that's the s-axis, y-axis, y-dash. This is origin point. Now this is first quadrant, this is 1/4. Quadrant means 1/4 part. First quadrant, second quadrant, third quadrant, fourth quadrant. This is the first quadrant. Quadrant means 1/4. 1/4. This is the first quadrant. Second quadrant means this whole plane is divided into 4 parts, equal 4 parts, 90 degree each measurement. This 90 degree angle, 90 degree angle, total 90 degree, 90 degree. This whole 360 degree, when divided into 4 equal parts, 90 degree each. Each part is known as quadrant. So this is the first quadrant. We count from here. First quadrant, second quadrant, third quadrant, fourth quadrant. This is second quadrant, cube. This is the third quadrant. Let me take, this is the fourth quadrant. Quadrant are taken here. Quadrant means 1/4. This is the first quadrant, second quadrant. Now in these 4 quadrants, what are the values of trigonometric ratios? That's the point. But let me just talk about these ratios. So we are the 4 parts here. In the first quadrant, as we suppose this is the triangle here, right angle triangle. Now if I measure this in terms of coordinates, this is x-axis, positive x-axis, and this is y coordinate here, this is theta angle. If I take here y is positive, above y is positive, this is plus, axis y is positive, x is positive. So both these 2 ratios, and this, let me take this r, this O, let me take OP, this 3 point is there, OPQ. Let me take this triangle, right angle triangle, OPQ, this is right angle. In the right angle we have OPQ. We have taken R as the hypotenuse, Y coordinate, X coordinates. Because these 2 are positive, all these 3 are positive, all ratios will be positive, so all are positive here. Here, this is positive here. Now in this case, if I take this, okay, let me now draw this right angle. Now this is the theta angle, let me take. Now this complete theta we have taken. Now this theta, because this x coordinate negative, but in this case x coordinate is taken as negative. Now this y is positive here, and this r is the length of the hypotenuse is always positive. We always take positive. R is positive in all. Here r, this is length of the hypotenuse. Length of the hypotenuse is positive. Is positive in all the four quadrants. In all the four quadrants. This R we have taken positive in all the four quadrants. Now if I just talk about this is the right angle. Now this angle, whole angle is theta. Now if I take this as the right angle, then this angle is separate theta up to this point beginning to end, up to this. Then what are the coordinates here? Now this y coordinate is negative. This is minus y, negative y. Or in the below origin, this is y negative, y dash. Y is positive above the origin, y positive. Here it is y positive. This y is positive. This is plus y, but this is minus y here because x is negative. Now in this case both are negative because y is negative, x is negative here in this right angle, and theta here we are taking. Now only the position. Now in this case y is negative but x is positive. This is plus x. This x is positive, y is negative. Now if I just describe sin theta as we talked about, this is theta opposite side of the angle is perpendicular upon base, perpendicular upon hypotenuse, sin theta positive, y upon r positive, sin theta. Let me write here in the okay, let me write quadrants and trigonometric ratios. So this is trigonometric ratios. Trigonometric ratios here in this down, and this is quadrants here. You will take here quadrants, and these are quadrants here. Quadrants that we take here with the first quadrant, second quadrant, the third quadrant, and next is fourth quadrant. Okay, let me take further here. All these four are there. This is the fourth one. This is the third one. Let me take third one. This is the second one. And this is the first one. First quadrant. All these are quadrants here. Here we are taking trigonometric ratios. Trigonometric ratios here. Let me take ratios. First is sin theta, or sine of any angle. Sine is trigonometric. Only we can write sine only. Okay. Sine in first is positive. First quadrant all are positive. This is positive here. Cos is also positive here. Tangent is also positive. Tan theta is positive. Tan of any angle you are taking. Tan, then cosec, positive. In first quadrant all are positive. Cosec, this is second, positive. Then fourth, theta, positive. In the first quadrant all are positive. Why? Because all the three sides are positive. Y positive, x positive, r positive. R is positive in all the four quadrants we have taken. Only x and y coordinate, x coordinate, they will be negative positive. That we will discuss about. In first quadrant, the sides are positive. X is positive, y is positive. X is positive, y is positive, y is positive. Now in the second quadrant, x is negative, try to understand. And this y is positive. but y is just around parallel to the y-axis. So this side is y coordinate, and this theta we have taken up this point. From this point to this here, theta is here. Okay, so in this case, again sin theta is y upon r, cos theta is negative, sin tan theta is also negative. Why? Because y upon minus x negative. Okay, so y upon x, tan theta negative, cos theta negative, only sin theta y upon r positive. This is positive in second bracket y. Cosec is r upon y. Cosec is also positive. Okay, or we can write here sin theta equal to y upon r. This is equal to y upon r in first quadrant. Here cos theta we will take x upon r. But in the first quadrant all are positive. This is y upon x, and theta is y upon x in terms of coordinate we are taking. The coordinates here we are talking about. Okay, so sin theta is y upon r, cos theta is r upon y, both are positive. Others are negative in the second quadrant. Cos, because cos will be minus x upon r, negative, is negative. Tan is negative because y upon minus x, that will be negative. Okay, second theta is negative because second is also base, this hypotenuse upon base is here negative. Okay, so second theta negative. Cos theta is also negative because tan is negative. Cot will be minus x upon y, is also negative. All the three in the second quadrant we have taken. Okay, so what we do? First quadrant all are positive. In second quadrant only sin, cosec, both are reciprocal of each other, they are positive. Others are negative. Other four ratios are negative. With these two ratios, tangent, sin and cosec, they are positive in second quadrant. So in the third quadrant, what we do? If tan theta is minus y upon minus x, that is positive. Sin is negative. This is r here, this side. So this is P here, we have taken OP, P dash, this is P dash, P dash, this is double dash, okay, no problem, this is P triple dash. Let me take P, P dash, P double dash, P triple dash, no problem. So now in this case, what we see, minus y, minus x, y coordinate is negative, x coordinate is negative. Wherever one negative will be involved, that will be negative. Here, sin theta is minus y upon r, negative. Cosec theta r upon minus y, negative. Tangent theta only is positive. Why? Because minus y upon minus x, perpendicular upon base. The tan theta will be positive, which is third quadrant. And cos theta, which is reciprocal, minus x upon y, minus x upon minus y, positive. Okay, that is how tan theta will be positive only in third quadrant. And others negative. So sin negative, cos negative, tangent is positive. These are the signs of trigonometric ratios in all the four quadrants we are talking about. Cosec is negative. Why cosec negative? Because r upon minus y. Hypotenuse upon perpendicular, r upon minus y, negative cosec. Second is base upon, r upon minus x. Hypotenuse upon base, second is negative. Cot is positive. Why? Because minus x base upon perpendicular, positive, minus x upon minus y is positive. Tangent is positive. Sorry, tangent positive, cot positive in third quadrant. In the fourth one, what we see here, x positive but y is negative. So this y along the lower side of, or the side, the y-axis below this origin, negative. This y coordinate is negative, minus y. Again, sin theta is minus y upon r. This is r here. R is positive, length of the hypotenuse. R is positive in all the four quadrants. Only these sides coordinates with negative, positive. In those two sides, if one side is negative, then it is negative. This minus y upon r, negative. Sin theta is minus y upon r, negative. Cosec theta is also negative because r upon minus pi. What about sin theta? Sorry, cos theta. Cos theta is base upon r, positive. Only cos is positive with x upon r. Second is r upon x, positive. Tan theta is minus y upon x, negative. Cos theta is x upon minus y, negative. Okay. This is how we calculate the signs of these trigonometric ratios in all four quadrants. Sin is negative, cos is positive here. Why cos positive? Because this is base upon x, base is positive, x is positive, x upon r. So this is base here. This theta we have taken. We consider this as a theta support. This side opposite, this is perpendicular upon hypotenuse, negative. Sin negative, cos positive, tan negative. Why? Because minus y upon x, negative. Cosec is negative. Cosec is r upon minus y. Yeah. Then second is positive. Second positive, why? Because r upon x, positive x. Positive. Now cot is negative. In the fourth quadrant, only cos second positive. What is the formula to remember this? The sign of all these trigonometric ratios in all four quadrants. There is all the students took coffee. On this ASTC means in the first quadrant. This is first quadrant, second quadrant, third quadrant, and in fourth quadrant. See, in fourth quadrant, what does it mean? All students took coffee. If we remember this, okay, all students took coffee. All students took coffee. That means all A in the first quadrant, all are positive. All students means S means sign. In the second quadrant, student means sign here. The sign opposite that reciprocal of that sign is cosec. Sign and cosec positive in second quadrant. All students. Third one is took coffee.